So we're going to graph y equals -3 cosecant 4x minus pi over 5 minus 1. First step is to factor out the b, or the 4, which means I'm going to actually divide pi over 5 by 4 or multiply by 1/4. And so then that's what I'm going to get. My amplitude is actually none. For cosecant, secant, tan, and cotan, there is no amplitude. However, I will use the 3 and the -3 as a guideline. The period for this problem is going to be 2 pi divided by 4, or b, and that comes out to pi over 2. The quarter period, I multiply pi over 2 by 1/4. I should really put this in another color so you can see it better. And I get pi over 8. The phase shift is pi over 20 to the right, and the vertical shift is down 1. So I'm going to start with my vertical shift. That's going to be my center. Okay, that's my midline. And then I'm going to go up 3, 1, 2, 3, and down 3. So when I do my middle high, middle low, those are the 3 lines I'm going to be using. Okay, so my quarter period, as we said, was pi over 8. My phase shift, as I said, was pi over 20. And so I'm going to find a common denominator, which looks like it's going to be 40. So I'll multiply by 5, and on this side I'll multiply by 2. And so my quarter period will be 5 pi over 40, and my phase shift will be 2 pi over 40. So this is going to get a little messy here, okay? So I'm going to start here. This is where I start, and then this is what I'm going to go by. Okay, so I go over to 2 pi over 40, and now I have to count 5 pi over 40s on from that. So I'm going to go 1, 2, 3, 4. And 5. So that is, sorry, someone came into my room. So 1, 2, 3, 4, 5. So then that's 7 pi over 40. 1, 2, 3, 4, 5. That is 12 pi over 40. 1, 2, 3, 4, 5. That is 17 pi over 40. And 1, 2, 3, 4, 5. That is 22 pi over 40. Okay, so I'm almost ready. Now the zeros, so let's just graph what sign would look like. So it's a negative sign. Sign always starts in middle. So it's going to start middle, but then it's going to go down because of the negative. It's going to look like that. So I could draw it dotted. You don't really have to, especially since my stylus doesn't really work very well dotted. And now I'm going to draw the asymptotes. So let me get a nice color for that. My asymptotes are going to go through where the zeros would be. So wherever there's a middle, like here, here, okay, that's where my asymptotes are going to go. And then the curve is going to go at all of the maxes and mins in the opposite direction. That is one full cycle. That's what that is, okay? Then the last thing I want to talk to you about is how to get the domain and the asymptotes. So the domain, get another color. Domain always is going to start with all reals except that what x cannot equal. X cannot exist, the graph does not exist at the asymptotes. So what is the first asymptote? The first one is 2 pi over 40 plus every increment to the next asymptote. So what are the increments? Well, this was here 12 pi over 40. This is 2 pi over 40. So the distance between them is 10 pi over 40. And so it's every multiple of 10 pi over 40. And the way we write that is we put a little n there. And that represents n, it's the first one plus n multiples of 10 pi over 40. So now for the asymptote equation, it's exactly the same, except that you don't use all reals and you just say x can equal 2 pi over 40 plus 10 pi over 40n, because that is the actual asymptote equation. And that's how you do it.